Data modeling is a huge part of every successful data analysis. So welcome back to Exam Island, where we're trying to learn and master the Microsoft Power BI tool over the next 100 days. Today is day 30, and we're going to continue from where we stopped from our previous live stream. We started a new course in this journey, which is data modeling in Power BI, and there are basically two types of data model, which is star schema and snowflake data models. Today, we'll be continuing and starting a new chapter in the data model course, which is dimensional modeling, which is actually creating dimension tables, which are major part of snowflake schemas and star schema. We have dimensional table and fact table. These are the two tables you need to create to have a successful data model. Without further ado, let's get back to learning. If you've missed previous lessons or previous live stream, you can catch up on the lessons on the channel. Go back to from day 1 to day 30 just to catch up so you can follow us along effectively. Also, all data set exercise files are Power BI files that we'll be using throughout the 100 days journey are already linked under the YouTube description. Do make sure to download those files and practice along with me. Without any other delay, let's get back to learning. We have a lot to cover, and welcome back to day 30. So we're actually using the DataCamp platform to learn so far. I'm currently subscribed to a 1-year subscription on the platform. I'll be renewing the subscription pretty soon if I'm not able to achieve what I'm trying to achieve in time. But not to worry, I'll renew and we'll continue from wherever we stop. Also, I'll just quickly go to the track section here so I can show you what it looks like. We're actually currently on the data analyst in Power BI career track. I started this journey with the data analyst in SQL career track. I completed 100 days of learning. You can catch those lessons on the channel also if you are looking to upskill yourself in SQL. So we are currently on the data analyst in Power BI career track. After we finish this data analyst in Power BI, the next objective is to start the data analyst in Python career track for another 100 days challenge. This year is probably the upskill year for me. So if you want to join me when I start the data analyst in Python career track, make sure to subscribe right now, put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. So let's get back to data analysis in Power BI. This career track, as you can see, we're actually 38% through the career track, and today is day 30. That means we are moving at a good pace. So while that is coming up, the career track actually contains 17 courses estimated for 40 hours. We've done quite a lot of justice so far to the content of the whole career track. We're actually on the course number 7 in the career track, which is data modeling. You can catch up on all this introduction to Power BI to data transformation in Power BI on the channel. So we just continue from here because we still have a lot to cover. Let's continue from data modeling. We're starting a new course, which is dimensional modeling, which is actually understanding dimension tables and tables. So if I quickly scan through this chapter content, we have dimensional modeling, facts versus dimension, which is fact table versus dimension table, creating a star schema, splitting data into fact table and dimension, loading a new dimension, create another dimension. I think this is the last chapter here, which we are going to come back to also. So let's continue from here. Welcome back to the channel.
Welcome back. I'm Sarah and I will be your instructor for this next chapter. Earlier, you learned that data models provide a conceptual representation of data elements and the relationships between them. There are many approaches to data modeling. We'll focus on one, the dimensional model. The Kimball model, otherwise known as the dimensional model, is one of the most popular approaches to data modeling. There are two key concepts in the Kimball model: facts and dimensions. Facts are the metrics from your business process. Dimensions provide the context surrounding a business process. These combine to form a star schema. The star schema's name comes from the way that facts and dimensions connect. We typically have several dimensions surrounding each fact. In this example, measures related to property sales are stored in the fact table, and the lender, salesperson, date, property, and payment type tables provide more context about each property sale. Huge amounts of data are organized in this way in data warehouses. Power BI is optimized to use star schemas over any other way of loading data. So Power BI is faster and easier to use with a dimensional approach. Let's take a closer look at fact tables first. A fact table typically has two types of columns: facts and keys. Facts are the measures or metrics from your business process. Examples include sales, employee count, or number of website visits. They are generally dates and numbers which we can aggregate in some way. Keys are how we establish relationships between fact tables and dimension tables. We expect fact tables to be tall and narrow. They have lots of rows, so we try to minimize the number of columns and how big those columns are. Here is an example of a fact table: property sales. Each row represents a property that was rented at a specific date. The first 5 columns contain keys or IDs that are used to link to each of the dimension tables. You'll find more information about the lender, date, property, payment type, and salesperson here. The last 2 columns hold the measures. Here we're tracking the rent in dollars and the duration of the rental agreement in months. Next, we'll look at dimension tables, which provide the context around facts. A fact may tell you how much or how often, but dimensions give the rest of the story: who did it, how they did it, where they did it, and so on. Dimensions are shared business concepts, usually in the form of a noun such as person, employee, customer, and vendor. Dimensions contain static or slowly changing data. Think of information like names, dates of birth, and height. Dimension tables are typically short and wide. They don't contain that many rows, but do contain a large amount of context for the facts. Let's take a look at an example. Here you can see the salesperson table. The first column contains the same key as in the fact table and can be used to combine the information from both tables. The table also stores additional attributes about each salesperson in the company. Here's that same star schema from before. In the Kimball model, dimensions are often used in multiple facts. These dimensions surrounding property sales could provide context to a different fact table as well. In a star schema, dimensions do not link to other dimensions. This chapter will continue with the census data about establishments active in the manufacturing sector. In the exercises, you will be creating a fact table that contains measures like number of employees, number of firms, and so on. Additionally, there will be more information about the establishment in the form of dimension tables. These include data on the industry, time, age, and geography of the establishments. Let's check your understanding of dimensional modeling.
So it says facts versus dimension. So the two main building blocks of a dimensional model are facts and dimensions. It is important to be able to distinguish between both. So consider the following star schema. We have orders, item, customer, employee, time, and location. Should the fields be part of the fact table or one of the dimension table? Clarify the cards as fact or dimension. Customer, join dates. Oops. Let's see another. Order dates. Oh, okay. Customer. Customer joined date. The day the customer joined. Definitely a dimension, but the other date is a fact. Quantity ordered, which is an whole number. Definitely a fact record. Item description. It's probably describing the item that was bought. We could use the item ID, a shipping zip code, string, shipping zip code. Oh, definitely a dimension. Order amounts, definitely facts. Customer date of birth is a dimension, the description of the customer. Let's log that in. We nailed it. So awesome. Breaking out attributes into facts and dimension is a common practice in warehouse design as well as data modeling in Power BI. So, okay, that's true. You need to understand the difference between the facts and dimension uh, attributes before you can understand building a successful data model. So let's continue. Okay, let's try to create a star schema.
Hey there, welcome back. Let's take a look at how we can actually implement a simple star schema in Power BI. In this demo, we'll take a data file and break it out into a fact and a dimension table. We'll also load a separate file as a new dimension. The first thing we'll do is go to the Data menu and then select Text CSV to load a CSV file. I'm going to choose the Establishment Survey dataset. I will select Transform Data to open Power Query. Let's take a look at the data first, before making any changes. As you can see, we have data about the geography of the establishments, both at the country and at the state level. It seems like we also have some information about the establishment size. However, this is just the ID. We don't know what the actual meaning of those values are yet. Lastly, we know the year the data was gathered, and the number of establishments is the measure that will go in our fact table. Let's split this file into a fact table and a geography dimension. I'll start by duplicating the query. This new query will form our dimension table. I'm going to rename it to Geography. We only want to keep the columns that provide more information about the geography. So I'll keep Country ID, Country, State ID, and State. I'll select them by holding the Shift key, and then I can keep only these columns by right-clicking and selecting Remove Other Columns. Now, I want to reduce duplicates to ensure we store the data in the most efficient way. To do that, I'll right-click again and click Remove Duplicates. Now, every row in the geography table is unique. Let's go back to the fact table. Since the geography information is stored in our new dimension, it's not necessary to keep it here as well, except for the ID. This is because we'll need to be able to connect the dimension to the fact. So we'll keep the state ID as a key in the fact table and remove the rest. There you go. Our fact table is done. I'll close and apply the changes made. In the data view, we can see both tables now. The last thing I'm gonna do is add a size dimension. As you can see, we have a size ID in the fact table, but we don't know what the IDs stand for. Let's fix that by loading another file. I'll click Get Data and select the Establishment Size dataset. As you can see, this file contains the actual meaning of the size ID, which is exactly what we need. I'll go to Power Query again, and I'm going to rename the table to Size. As you can see, there are a lot of duplicate values, so let's remove those. That looks better. Let's close and apply and go take a look at the data model. To get a better view of the data model, you can collapse the properties and fields panes on the right. There is also a slider to zoom in and out of the data view on the bottom right of Power BI. Here we can see the fact table and the two dimensions. The only thing left to do is to make sure there is a relationship between the fact table and the size dimension. Size is connected to Establishment Survey by the size ID. That's it. Using this star schema, we can start creating reports to get insights about the establishments, sliced by geography and establishment size. Your turn.
Oh, it's easy peasy. So let's create this data model. So we want to build our own data model from scratch now. So splitting data into fact and dimension. So data sets will frequently come in a wide format containing both fact and dimensional data. Breaking these files out into fact and dimensions will provide queries and can improve performance or on larger data sets. So in this next few exercises, we'll be creating the following star schema. So we want to have establishment survey, the time as a dimension, the industry as our dimension, the age as our dimension, while the establishment survey is going to be our facts table. So let's start by creating the establishment survey facts and industry dimension table. So it's a establishment survey facts and industry dimension. Okay, I want to create this first two table. So open the Power Query Power BI desktop file name, split data set from the exercise folder on the desktop and go to the Power Query. So I'll just open the file from my local machine here. So I'm going to up exercise 3.1. So that is coming up. So duplicate the business establishment survey query and rename it to industry. So I want it to come up. Okay, we're up. I'll just go to the Power Query tab real quick. So we have the file here. So I need to point to the file, to the data set in my local machine here. Data set establishment survey. So I've seen that. I'll just copy it as file paths. I go to the source here and edit the source to my own source right there. It's a CSV file. Click on OK. And boom, we have the data set. So let's just quickly study what we have here. So that we have, let me just promote the headers, run through these steps. So we have the ID. So it's an establishment survey. We have the ID, the age code, the year, the NAIC code, the number of firms, the number of establishments, number of employees in the establishments in each firms. And we have number of establishments born, number of establishments existed. We also have the description of the establishment. We have the industry code, industry group, subsector code, subsector, and quite a lot of information. The sector that industry or firm is. So what we need to do now, you can see most of the records there, they are duplicates. So we don't have any. I think this is probably the full whole record. This is over 99 plus rows. Now 999 plus rows. Over 1,000 rows, I guess. And we have 16 columns there. So what we need to do is just follow the instruction real quick. So duplicate the business establishment survey query and rename it to industry. So I want to create an industry out of this. So the industry, let me see. So I want to go the industry. What we need to do is to get the unique industry out of this table. So I'll just quickly duplicate this, duplicates. So we have, so I'll just rename it to industry. What are we to rename it to? I'll rename it to industry. Yeah, we have to rename it to industry. Industry. We've done that. So following the instruction, so keep only the following columns in the industry table, which is this code, description, industry group code, industry group, subsector, subsector code, subsector, sector code, and sector. Okay, I'm going to remove the duplicate. Let me go back there. We need to create this first column and the code description also. Let me look at for the code. I'll just hold down the control key on my keyboard because they're actually all scattered everywhere. So I just create this code description. Oh, I'm holding shift error. I'm supposed to use the control key to select random columns. So holding the control key, so I've selected two of the columns. Yes. So the next columns are industry group code, the industry, subsector code, or subsector, sector code, and the sector. Okay, let's go to industry group code. This is it here. Industry group code. Then the industry group. Next is the subsector code, subsector, sector code and sector. Okay, let's look for it. Subsector code, subsector, sector code, and finally the sector. So all I need to do is just select, right click gently and say remove other columns. So we should have these columns left. If you follow the instruction here, we should have all these columns 1, 2, 3, 4, 5, 6, 7, 8. So we should have 8 columns left. Let me quickly check. Correct. Looking down here, we have 8 columns. So what we need to do now is get rid of duplicates. So we need to right click and say, probably I should select everything. Let me select everything. Everything is selected. I can now say remove duplicates. Let's see. Aha, you can see we have just removed duplicates. So what we actually have is we have 8 sector or 8 industry in the old data sets. You can see. Oh, all of them are under manufacturing industry. Oh, I need to be sure that is correct. But I think we are good to go since we have the codes are unique. You can see the industry group code is unique. So we are on track. So following the instruction, return to the establishment survey query and remove the columns you just added to the industry. Okay. Is the key we use to connect to the, so we want to remove all this column we added in the industry parts of the table. And we're going to make sure to keep the NAIS code, as this will be the column that will be, this code will be what we use to connect to this table here. So this is our primary key here. It's going to be our foreign key here. So if I just look to, I want to remove NAIS code and NAIS description. So I want to remove NAIS code, control, the description, what else I want to remove. Ooh. So I have to make sure I don't remove this NAIS code. This can be removed, and this will be our primary foreign key here. So I'm going to start with the description, industry group code, industry group code, industry group. Then the next one is definitely the subsector code, subsector and sector code. Definitely subsector, this, and the sector. Definitely other. Let me just double check real quick to see that subsector code, subsector, sector code, and sector. So this time I'm going to remove these columns rather than removing other columns. Remove these columns I've selected, and we have this NAS, this column remaining as it is also here. So it is the primary key here, it is the foreign key here. That will be our connector there. Our key is to connect both tables together. So if I move on, go to the model view to verify that there is a relationship between industry and establishment survey. Okay, so let's close and apply. It's going to do perform its magic. So by default, it should say, it should create a relationship by default. Let's check, and boom, we're on track. We could see, just build out a quick data model in minutes. You can see one to many because we have one instances of this here. You can see this. You can see this is our primary key. These are our foreign key here. If you pay attention to it, so we are on track. So okay, let me just read this. It says if for some reason a new table is not showing up in the model view, you can manually add a relationship using the manage relationship in the O. There's a relationship already, so we don't need to do that. Go to the report view and create a new clustered bar chart visual. Okay, let's drop in a new clustered bar chart chart right here. So with the subsector column for the dimension table and the axis as the axis and average number of employees from the fact table as the values. So let's bring in subsector. So we could bring the subsector from anywhere, definitely from this establishment here, from the industry. That's where the subsector is going to be. Subsector right there, and number of employees in the establishment, number of employees, this is here. So you could see it right there. So it's going to drop into want the average. So what I need to do is, you can see this is in billions. So what we need to do is just get the average. All I need to do, let me just switch off my camera real quick. Go to the sum here. You can see the aggregation is sum. I could just change it to average real quick. We have average here. I think this is fair. More readable. So if you go to the question tab, it should say which subsector counted the highest average number of employees. That should be food and manufacturing. Let's type in food. Is it food manufacturing? Okay, they are all in the manufacturing sector. So it is food manufacturing. Cool, we nailed this. Great job. You just created a fact and a dimension table from one single data file. You're on your way to creating your first star schema. Let's add some more dimensions. So we only have one fact table, which is interesting, which is this establishment survey. We need to create more dimensions table so we can slice and dice our data from any dimension, from any category that we like. Quite interesting. So let's add this is our fact table, usually large. This is our dimension table. So let's add some more dimension table. If I go back to the instruction, we're now loading a new dimension. So sometimes you want to import a separate file as a dimension. This will further extend the amount of relevant information you can learn given your fact data. In our case, it will be nice to have some more time-related information. Adding a time dimension will allow us to aggregate data not just at the year level, but also the decade or even country level. Let's continue with our star schema from before. So we've added the industry and the establishment, which is our dimension table. This is our fact table. We want to add a new dimension table. It's probably time or age. So let's move on to next. Import the file name time.txt from the dataset folder on the desktop. Okay, we have time here. It's a text file. So I'll just go to the view tab here. I could make this small a little bit. So I go to get data. This time around, we're doing a CSV file, a text. So this is it here. We'll see we just have year, decade, and country. Cool. So just curious. So let's load and transform. Definitely we are loading and transforming. So go to the model view and verify that there is a relation by the year column. So we have, okay, we have the year column. So the year will be our primary key here. You can see the years are unique: 1960, 62, 61, 62, 63, 64, 65, and so on. Probably just transform and let's just take a peep in the Power Query editor. You can see we have time. So it is going to connect to this establishment based on the year column here. You can see, yeah. So I'll just close and apply. So while that is loading, the instruction says go to the model view and verify that there is a relationship between time and establishment survey tables defined by the year column. If I go to the model view real quick, I like not the table view. If I just bring the time part here, let's make it here. You can see there's a relationship. This is 1. We may not see this part. Or it is hiding there. Why is it hiding? Because we're supposed to be seeing 1 to many, but the ones is there. So there's a relationship. You are probably not seeing that clearly. Okay. You can see 1 to many. You can see the relation is saying 1 to many. One from here to the many part of here. I'll just cancel that real quick. If I double click, it will take me to the relationship, edit relationship dialog box. One to many, cross filtering, just single. These are technical stuff. So there's a relationship. We are good to go. So the next instruction now says return to the report view and add a new slicer visual, slicing on decade from the time dimension. So I want to add the slicer here. Our slicer is going to come from here. This is the slicer. So what I want to add to the slicer is time. I think we want to add a decade. Here, a decade dimension. You see, so we could look to a certain time period. Let me just make it smaller. This is better. Adjust the size of the slider in the page until you see the option and change the slider to a list of values rather than a range. So let's change it to a list. I could just go to the format slider here or slider settings. Uh, it should be settings here. So we could just take it to a list here, vertical list. Here you can see the list is better like this. We could change the slider settings right here in the format tab. I just close that and make it quite bigger. You can see the decade. So the instruction now says how many employees did the food manufacturing subsector count on average during the 90s? The 90s. Okay, we need to select the 90s. Oh, why do I select? Okay, hold up. The note shifts. Oh, during the 90s. Let me read that instruction again. How many employees did the food manufacturing subsector count on average during the 90s? I should be able to select multiple. Let me clear the selection first. Let me see if I can select multiple. This is 1960 or 1970, 1980, 1990. So this is the 90s. So on average, they should be doing something like 304 average number of employees over 3 million. That is 30, 40, 406.61. Let me see if I can input that. 30, 40, 406.61 on average. Oh, I didn't get that. So I need to look at that pretty well. On how many employees did the food manufacturing subsector, subsector count on average during the 90s? Yeah, these are the subsectors during the 90s. Hmm. I'm definitely confident if it's asking me during the 90s. So it is the 1960, 1970, 1980, 1990. But let me see. If you have to format this, let me see if I can format this real quick. Okay. Since I'm not doing I'm seeing if I can. Okay, let me see if I can format it to decimal places. Or let me just remove the number of decimal places and see if it's going to accept it. Nope. It's not accepting that calculation. Hold up a minute. Food manufacturing. So I'm selecting the right sector, subsector. How many employees did the food manufacturing subsector count on average during the 90s? On average, this is subsector food manufacturing. Average number of employees 30, 40, 46. That is 3 million. That is 3,030,406. So I'm correct. 3,030,406. So looking at the number here, okay, let me see. During the 90s. Hold up. 90s. Okay. Let me unselect this. Let me only select the 90. This is 80, 70, 60. Oh, my mistake. So I was looking at 1990 as the 90s, but that's probably the 90s. Probably this is the 1990. So 90s. So that should be 3 million. That is 3,164,402. So let's log that in. 3,164,402. Let me take a peep at that again. Okay, 3,164,002 on average. Correct. So it's only the 9090. So I was doing a mistake of interpreting these 9060, 9070, 9080, 90s, 1990s. English is at some time. But we got that. So we're only looking at 1 year, 1 decade. So throughout the 1990s. So from 1981 to 1990. So that is the decade there. So we got that. So that was good. By adding the time dimension, we've made it possible to slice and dice the data at other levels than what was present in the initial data set, which is the year. That's going to be interesting to see. So we are creating another dimension, which is the last part of this chapter. So time to add a final dimension, age. In the data, you can see that we have information about the age code for each establishment, but we do not know what the actual meaning of those values is. Let's load another file as a new dimension to allow for slicing by establishment age. So I want to add this last table, which is the age dimension. Import the file name establishment age.csv from a data set. So let's import one last file. I can just save my progress there. So let's import a CSV file this time around, which is this establishment age right here. You can see we have the age code, establishment age, since total. Okay, let us just transform and see what it looks like in the Power Query editor. Quite straightforward. Okay, total establishment age total 0 years, 1 year, 2 years. Okay, let's look at the age. We have the age code here, which is either 1 to 70. So 1, what this 1 means right here, we know what 1 means is total. You can see what 1 means total. 10 age code means 0 years. 20 age code means 1 year. So this one is having age code of 1, which is total. What does total means? So they have what's they actually intended with the word total there. But let's continue. That there's always something called uh, data dictionary. So they didn't provide the data dictionary for us, so you can't really understand what each of these table, what the information they're trying to pass, and what each column is trying to pass. In a normal, in a good setting, when you inherit a table, you are supposed to inherit it with the data dictionary, which tells you all the information about each column in each table. Well, let's work with what we have here. Let's close and apply. So going on go to the Power Query and name the table age. Oh, we have to name it age. Let us go back real quick and name it age establishments age. You can close and apply. So remove the duplicate values from the data set and then close the Power Query. Oh, we need to go back one more time. So let's remove the duplicates from data sets. Okay, let's remove the duplicate. We have duplicates here, actually. So remove duplicates and boom. So we have a age code of 1, that is total, age code of 10, 0 years, age code of 20, 1 year, 30, 2 years, and so on. So 150 left censored. So let's close and apply now. So it now says navigate to the model view and connect the age dimension to the establishment of to the establishment survey facts by age code if this is not the case yet. Okay, so we could see right from the model view. Let's check. Oh, it is not, there's no connection yet. So we need to connect many to one. I can drag it from here. I'll drag it from here. It's still going to be, so I can do it like this. So well, earlier, this relationship was created automatically. I have no idea why this wasn't created automatically, but if not, I could just drag from the many side to the one side. You can see then the relationship has been created for us. You can see one to many. Same here, one to many. So we just built a super cool star schema data model without stress. So return to the report view and add a second slicer using establishment age from the new age dimension. Okay, let's add a second slicer right here. We just drag this here. Just bring in one more slicer. So this time around, I can just call this. Let's go to the age and select the establishment age. So you can have 0 years, 1 year, and so on and so forth. Cool, interesting. So the instruction now says, how many average employees did 3-year-old firms in the food manufacturing subsector have during the 90s? So we have to use the 90s and 3 years. Let me see that again. It says how many average employees did the 3-year-old firms in the food and manufacturing subsectors have during the 3-year-old firms. So if you say 3-year-old firms, probably 3 years and above. Okay, we have 3 years, right? Say, oh, it wasn't arranged very well. So let's select 3 years here. Okay, we have 3 years here. And the 3-year-old firms in the 90s under food and manufacturing, they are not performing well. They're probably the second to the last. But they have this is 437,388 employees. That is 437,388 employees. 437,388 employees. Cool, we nailed it. Awesome. You just created your first star schema. In the next lesson, we will look at another type of schema, the snowflake schema. And I've never created a snowflake before. That'll be interesting to do in the next lesson, which is day 31 of the live stream. I think we've completed all the lessons in this dimensional modeling, and we were able to do that under 43 minutes. That's quite fast, and we were on track. So don't worry, you have access to all the data sets, so you can practice and build your own star schema. Also, I've linked every data set under the in a link with a link under the description. Do make sure to get them from those links and download those files so you can practice and build your own star schema also. So the next one is what is called snowflake schema. So that will be on day 30. Today is day 30, on day 31st of the live stream, which is tomorrow. Of the live stream for today. So if you found value in this live streaming, in this Power BI learning journey with me, do well to support the channel by giving the video a thumbs up. Make sure to give it a thumbs up and let me know your thoughts in the comment section. Also, do not forget to subscribe, hit that subscribe button, hit that red button, and put on the notification bell so you'll be the first whenever I go live and ready to practice and upskill myself in Power BI so you can also do the same with me. Alright, have a wonderful day. Don't forget, support the channel by hitting that subscribe button, and I'll see you on the next day of your live stream, which is tomorrow, day 31. Bye for now. I look forward to seeing you on the last day of your life, which is day 100.